What is stoichiometry?
Stoichiometry is solving problems using a balanced chemical equation. The number of moles of a substance can be related to its molar mass and number of molecules. It can also be related to the volume at standard temperature and pressure STP. Stoichiometry may also include solutions through molarity. The relationship among moles, mass, molecule, and volume is given below. The diagram shows that the given quantities, whether mass, concentration, or volume, must first be converted to reactant moles. The number of moles of reactants calculated should be related to the number of moles of the product based on the balanced chemical equation. And depending on the unknown, this number of moles of products could then be converted to mass, concentration, or volume.
So let us now proceed to solving problems involving stoichiometric solutions. So we have here a sample problem. What volume of 0.300 molar sodium hydroxide is required to react completely with 2.50 grams aluminum nitrate? So the first thing that we're going to do is to identify whether our chemical equation is balanced. And as you can see right here, our chemical equation is already balanced so that we can now proceed to finding or solving the volume of our sodium hydroxide. We have here the given from the problem: 2.50 grams aluminum nitrate, 0.300 molar sodium hydroxide, and the missing, which is the volume of sodium hydroxide. We also have here the solution for molar mass of the aluminum nitrate, where I just sum up all the atomic masses of each element from the compound. Since we already have the mass of aluminum nitrate, we are just going to use that mass in solving the mole. So, we're just gonna multiply 2.50 grams to our desired product, which is the mole of aluminum nitrate, and divide it by the molar mass. Then, cancel the same units and calculate, which will then give us the answer of 0.0117 mole of aluminum nitrate. After solving the mole of aluminum nitrate, the next step is to solve for the mole of sodium hydroxide. We're going to be using the mole of aluminum nitrate in getting the mole of sodium hydroxide by multiplying and dividing it to the stoichiometric ratio of sodium hydroxide to aluminum nitrate in our balanced chemical equation. So, 0.0117 mole of aluminum nitrate times 3 moles of sodium hydroxide over 1 mole of aluminum nitrate. Cancel the units and calculate. The answer will be 0.0351 mole of sodium hydroxide. After solving the moles of the compounds, we will then apply molarity. As we all know, the formula of molarity is M is equal to moles over liters. And since liters is one of the units in volume, we are going to derive the formula into liters is equal to moles over molarity to solve for the volume of sodium hydroxide in this problem. Now that we already derived the formula, we can now substitute the values of moles and molarity. So that will be 0.0351 moles of sodium hydroxide divided by 0.300 molar. Calculate and the answer will be equal to 1.17 liters. And to convert liters into milliliters, we just need to multiply 1.17 liters to 1000 ml. And since 1000 ml is equal to 1 liter, we now have the final answer of 117 ml. Therefore, the required volume of sodium hydroxide is 117 milliliters.
Let's now move on to our second question. Using the same equation in number 1, what mass of aluminum hydroxide is produced from a 25 ml 1 molar aluminum nitrate? So as you can see right here, this is the given chemical balance equation, and this is just the same as the given in number 1. So since this equation is already balanced, all we have to do right now is move on to the solution or the process on getting the mass of aluminum hydroxide. So this is like the process. First, we have to solve for the molarity, and then the mole of aluminum nitrate to the mole of aluminum hydroxide, and lastly, the mass of aluminum hydroxide. So first and foremost, we are going to write down our given, which is 25 ml of aluminum nitrate multiplied by 1 liter over 1000 ml to cancel ml right here. And then let's move on to molarity. Since our given is 1 molar of aluminum nitrate, let's write it down here. 1 mole over 1 liter to cancel liter out. After that, let's now move forward to the mole of aluminum nitrate and mole of aluminum hydroxide, which we're gonna base on the given chemical balance equation right here. And we can see that both aluminum hydroxide and aluminum nitrate has only 1 mole, so let's write it down here. 1 mole of aluminum hydroxide over 1 mole of aluminum nitrate. And lastly, we have to multiply the given mass of aluminum hydroxide. But first, we have to calculate the molar mass of aluminum hydroxide. To determine the molar mass, multiply the number of atoms in the elements by their atomic weight and add up the weights. So the molar mass of aluminum hydroxide is equals to 78 grams. So let's write it here. 78 grams of aluminum hydroxide over 1 mole of aluminum hydroxide. Don't forget to cancel mole here and mole here. After writing the whole process out, you can now rewrite all that we have to put in our calculators. So let's write down 25 multiplied by 1, multiplied by 1, multiplied by 1, multiplied by 78 grams of aluminum hydroxide over 1000 multiplied by 1, multiplied by 1, multiplied by 1. So all that you have to do right now is just put in this thing in your calculator, which gives us a total of 1.95 grams of aluminum hydroxide. So here is the final answer.
Another application of stoichiometric problem is titration. Titration is a process where the concentration of an unknown solution is determined by reacting it with a solution with known concentration. The amount of standard solution to be added is determined by the endpoint, which is indicated by a color change. The endpoint indicates that enough of the standard solution has reacted with the unknown solution. The standard solution should be well prepared and must come from a stacked solution. Preparation uses dilution method. Only solution of lower concentration can be prepared from stock solutions or solutions of higher concentrations. Dilution adds water to the solution of known volume and concentration. The number of moles of solute does not change in dilution because the amount of solute does not change. Only the volume of the solution changes. The relationship is expressed mathematically. Moles solute concentrated solution is equals to moles solute diluted solution. V sub 1, C sub 1 is equals to V sub 2, C sub 2. Where C sub 1 is the initial concentration, V sub 2 is the initial volume, C sub 2 is the final concentration, and V sub 2 is the final volume. This shows how 1 ml stacked solution becomes less concentrated as it undergoes process of dilution.
So, a small volume 1 ml of stock solution is taken and transferred to a test tube containing a larger volume of diluent. This creates a 1/10 dilution as the original solution is now diluted tenfold. The process is then repeated, taking 1 ml of the 1/10 dilution and adding it to another test tube with 9 ml of diluent, resulting in 1/100th dilution. This pattern continues, creating a series of progressively more dilute solution. Each dilution step decreases the concentration of the original solution by a factor of 10. This technique is useful in preparing solutions with very low concentration or for experiments that requires a range of concentrations.
So this one is an example of stoichiometric titration problem. As you can see right here, we have a given of a chemical balance equation, but since this is already balanced, this equation is already balanced, let's just move on to the problem. What is the concentration of nitric acid solution if 25 ml reacts with 38.5 ml of 0.145 molar tripotassium phosphate. So here, this is like the process on how to solve this problem right here. The first step is to get the number of moles of tripotassium phosphate. Since we already have the given of 38.5 ml of 0.145 molar of tripotassium phosphate, let's just write it down here. 0.145 mole of tripotassium phosphate over liter multiplied by 0.0385 liter of tripotassium phosphate. If you're wondering what happened right here, all I did is divide 38.5 ml to 1000 ml and converted ml to liter to cancel liter right here. After that, we have to get the stoichiometric ratio of nitric acid and tripotassium phosphate from the given balanced chemical equation right above here. So as we can see, we have a given of 3 moles of nitric acid over 1 mole of, right here, 1 mole of tripotassium phosphate. The last step is to convert the number of moles of tripotassium phosphate by dividing it with the given volume of nitric acid. So what we have to do right here is just convert the number of moles of tripotassium phosphate. So 1 over 0.0250 liter of nitric acid. So this is the final process. All we have to do right now is to rewrite all the numbers and put in all of this in our calculators. But don't forget to cancel mole right here. So let's rewrite 0.145 multiplied by 0.0385 multiplied by 3 moles of nitric acid multiplied by 1 over 1 multiplied by 1 multiplied by 0.0250 liters of nitric acid, which give us a number of 0.668 mole over liter. Cancel. So that's it, guys. I hope you understand something about this equation right here.
For the second sample problem, what is the final concentration of 25 milliliters of 3 molar sodium hydroxide if 10 milliliters of water is added to it? Using the formula V sub 1 C sub 1 is equals to V sub 2 C sub 2, where V sub 1 is the initial volume, V sub 2 is the final volume, C sub 1 is the initial concentration, and C sub 2 is the final concentration, which is what we are going to solve now. So the first thing that we're going to do is to identify the given from the problem. So we have here the given of V sub 1 is equal to 25 milliliters, C sub 1 is 3 molar, V sub 2 is 10 milliliters, and C sub 2 is our missing. So the first step of our solution process is to derive the formula that we are going to use. So from our formula V sub 1 C sub 1 is equal to V sub 2 C sub 2, we're going to divide both sides of the equation with V sub 2, since C sub 2 is our missing in this problem, which will then give us the derived formula C sub 2 is equal to V sub 1 C sub 1 divided by V sub 2. Now that we already have the final formula, we can now substitute the values from the given. So we now have 25 milliliters times 3 molar over 10 milliliters. Cancel the unit milliliters and calculate. So we now have the final answer 7.5 molar. Therefore, the final concentration is 7.5 molar.